Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're continuing looking at kinetics. Today over here, we're going to say we're looking at rate law. Now, rate law is defined as the means of determining the rate of a chemical reaction. So how we find out by just looking at the equation how fast a reaction takes place. We do that with our chemical reaction, okay? And the rate law itself is expressed as rate is equal to a constant times the concentration of the first reactant with each of them raised to an exponent. Now you'll notice those don't have anything to do with the coefficient. So it's not like equilibrium, which we talked about last year. All right, so how do we find these values? Well, let's take a look at a example of a chemical reaction. So copy this all down. We have the first reaction where the concentration of ammonium is 0.0100 molar, concentration of nitrite is 0.200 molar, and the rate of that reaction is 5.4 times 10 to the minus 7th molar per second. In the second one, 0.0200 molar and 0.200 molar is equal to 1.08 times 10 to the minus 6 molar per second. And the last one, 0.0200 molar and 0.400 molar is equal to 4.32 times 10 to the minus 6 molar per second. Now, why do we do it in this particular way? Well, if you look here, you'll notice in the second and the third one, the second reactants are the same, and we'll use that to eliminate it. And then in order to define the other one, you'll notice that the second and the third are the same. So again, they'll do the same thing. So what we're going to do here is take our reaction rate expression, and we're going to start off with the second and the first reaction. So we'll take the rate of the second over the rate of the first. When we do that, we put our values in, and the rates are 1.08 times 10 minus 6 molar per second divided by 5.4 times 10 minus 7 molar per second. Now we do that. If you notice it here, these are the same. So they'll cross out, my K's will cross out, and we're just left with this expression. Now if we divide that, we get 2 to the x. And we divide this, we get 2. Well, what 2 raised to what power is 2? Your algebra skills, you should know that's 1. So for my ammonium, the expression there is 1. All right, let's do then for the second coefficient, we're going to compare the third and the second. So we're going to put the third rate over the second rate, put our values in. And again, my ammonium is going to cross out and my constant is going to cross out. And when we put our rates over each other, we get 2 to the y is equal to 4. Well, 2 ways to what value is 4? That's 2. So the coefficient there. So that's my rate law. That's how we find it using the expressions. All right. So here's one for you to work through. Pause the video. Work through this. Do the same thing we just did if you have to review back. Remember, any questions, ltswpd@gmail.com. Remember, like, subscribe, share, comment, anything you can do to help out, just to let people know about it. All right, ready? Here are our answers. Right there. So our rate here is equal to K times the concentration of ammonia squared times the concentration of hydrosulfuric acid. And that is our expression. Now, there's one other thing that we can do here, and that is to find an order reaction. Order reaction is means expressing the rate law. So we express how they are. So let's take a look at these 3 examples. In the first one, we take the coefficient. This is 1. This is 1/2. We're going to add them together. If we add them together, we get this is a 1.5 order reaction. For the second one, I only have 1 here, and it's assumed to be 1, so that's a first order reaction. So for the third one, how will we determine that one? Pause the video, try it on your own. You add those together, each of those is 1, 1 plus 1. This will be called a second order reaction. Now, tomorrow we're going to practice. The day after, we'll talk about specific equations we use for first and second order reactions. But for now, that's what you would have there. So in the examples we've done before, they would both be third order reactions. All right. So last thing we're looking at before we finish up here is determine the rate of law constant, that K value, and then calculating the rate. How we're going to do that? Well, let's take that first example we did. the rate is equal to K times the concentration of ammonia to the first times concentration of nitrite squared. Again, this is third order reaction. Okay, let's go back and look, and we're going to use that first reaction just because it's the simplest one. And we're going to take and put our values in. So we have 5.4 times 10 minus 7th molar per second is equal to K times the concentration of 0.0100 molar times 0.200 molar squared. Now we're going to solve for K. K is going to be equal to the rate divided by concentrations. And I have to look at units here. So when I do that, my molars cross out. It's going to be molars per molar squared second. We're going to use that then, so that's my rate constant, my K value. We're going to use that to find the rate at specific concentrations. So we'll take our expression again, plug our K in, and plug in the concentrations that we know. When we do 0.0014 times 10, so 0.0014 per molar squared second times 0.1000 molar to the first times 0.100 molar squared. When we plug that in, equal, you should get 0.000014 molar per second, or 1.4 times 10 to the minus 6 molar per second. Those are our answers. All right, makes sense? Let's try the other one. Let's try the other reaction. And I want you to find the K value again, and I want you to find the rate at these sets of conditions. Remember, we're looking at this, so we're going to look at the first set of values to find our answer here. Okay, so again, find it, pause it, work through it. Ready? Here we go. Those are answers. So our constant is 0.0270 per molar squared second, and our rates are 0.000508 molar per second, or 5.08 times 10 minus third molar per second. That's it. Hopefully not too bad. Take care. God bless. Bye.
There we go. All right. Bye.